some time. I think we are live. If you guys can hear me properly, write in the chat while and let's give some time for others to join as well. And meanwhile, we can discuss about the problem that I'd given for homework last day. We can discuss around that. But yeah, like let me know if you guys can hear me properly. If you have some doubts from the last day, or if you have completed the homework that was given. So good news today, I will not be giving you any homework, but from the next class there will be a lot of homework. So be prepared for that as well. And other than that, yeah, let me know like if you guys can hear me, or let me check myself if I can hear. Yeah, I think I can hear myself. So hey Rajesh, thanks for joining in. So okay, so yeah, let's actually quickly look into like last day's homework. So it was asked if two trees are identical. So last day we solved two problems, like you had to check whether it was a balanced tree, whether it was a binary search tree. These were the two problems that we solved, and a follow-up question on that, like you have to determine if two trees are identical. So for example, these two trees are identical, but these two trees are not identical. So I think it was pretty simple. Like you can similarly do a DFS and search on like if the left subtree is identical, if the right subtree is identical, and you can then just if the current values are identical, you can just return a true, right? So I'll not go into details about the implementation here, but I'm just like hoping that you're able to solve it. You were able to solve it, or was there any difficulty, like you faced any difficulty for which you were not able to solve? So you can tell me that if you had some difficulty for this question. And if you haven't solved this, yeah, I would expect you like just go today and solve it itself, as you don't have any homework for today. And from the next class I'll be giving you around 4 to 5 problems, or 3 to 5 problems daily. Just make sure that you complete those when you are like after the class, or like you will get a 1 day or 2 day break, right? So just complete them so that you are ready with those in the next class, so that we can quickly like for 5 minutes we can just discuss around them, and then we can start with the agenda, right? So just make sure that you do that. Other than that, yes, I think a few of you have joined us, so we'll start with today's agenda directly. Before that, let me know if you have any questions. I'll wait for like maybe 1 minute more, and then we'll start. So let me know if you have any questions. If you have any questions from your side, any doubts that you have, let me know. After that, we'll start with the agenda for the day. Let me know if you have any doubts. Okay. Uh, I don't think you have, so let's get started. Okay, so the first problem we'll solve today is called the minimum number of platforms, and after that we'll solve the problem minimum number of jumps, right? So I want to spend more time on the second problem because that is a bit difficult, right? So for the first problem, we'll try to get it done as quickly as possible. It's a pretty simple problem. I will also let you know about a cool trick that you can use to solve these problems. And quickly we'll switch to the second problem because I feel that we should spend some more time there. Okay, so the problem is minimum platform. It tells that you are given the arrival and departure times of all the trains that reach a railway station, right? So there's a railway station where there are trains coming in, right? So you're given the arrival and the departure time for all the trains, right? Find the minimum number of platforms required for the railway station so that no train is kept waiting, right? So you have to tell what is the minimum number of platforms that you need to be there on the railway station so that no train is waiting. Okay, so what do we mean by train is waiting? So let's say you have a platform, you just have one platform. So in that case, if two trains are coming together at the same time, or let's say one train is already there in the platform, a second train is coming in, that train cannot come, right? Because there is only one platform and one train is already occupying that. Or if there are two trains coming in at the same time, they both of them cannot come. One can come, the one has to wait. So that is basically waiting. So if you have two trains that are overlapping, their time interval is overlapping, in that case you need two platforms, right? If you have five trains whose time intervals are overlapping, right? So in that case you need five platforms. So you have to tell what is the number of platforms you need so that none of them are waiting. Basically it means what is the maximum number of trains that have some overlapping time interval. What is the maximum number of trains that has some overlapping time interval? So arrival and departure time can never be the same for a train, but we can have arrival time of one train equal to the departure time of another train. At any given instance of time, the same platform cannot be used for both departure of a train and arrival of another train. So it tells that if the arrival time of one train and the departure time of another train is the same, then you cannot use the same platform for both of them. Basically this will depart only after one more unit of time the second train can arrive. So that basically that train has to wait, or you basically need a new platform for that. So in such cases we need different platforms, right? Sort according to departure time. Yes, very good. So actually Suraj has given a solution already and it is actually correct, but again, like, let's understand the problem first, right? So arrival and departure you have, and I'll actually, Suraj, I'll also tell you a trick with which actually you can solve these questions very very easily, right? So whenever there is a overlap problem, or you have to see if two things are overlapping or something, there's a very cool trick that we can use that will help us solve such problems. So I'll talk about that as well. So see, this train is coming at 9 in the morning, 9:00. So just assume that it's 9 in the morning. It's actually RR minute standard, so it's 9 in the morning only, but it's given to us as an integer, right? So 9:00, it's coming at 9 in the morning, it's leaving at 9:10, right? This second train is coming at 9:40, it's leaving at 12. So train 1, let's actually write these down, right? So let's open our whiteboard. Yes, right. Just give me some time, or give this whiteboard some time to open up. Meanwhile, does anyone have any doubt with the question? So the first train is coming at 9:00, 9 in the morning, it's leaving at 9:10. The second train comes at 9:40 and 12. So there is no intersection between the first train and the second train, right? So the first train can come and go, and after that the second train is coming. So there is no intersection. So till now we just need one platform. Now let's come to the third train. It comes at 9:50 now and leaves at 11:20. Now when it comes at 9:50, if you see at 9:40 to 12, one train is already occupying the platform. So this train cannot actually enter the platform. So this train has to take another platform, right? So two platforms are needed. So this train is there, this train is there, right? Another train is coming in at 11. Now at 11, how many trains have overlapping time? At exactly 11, how many trains are there in the station? There are three trains, right? One, two, three. This train will leave at 12, so this is there. This train will leave at 11:20, so this is also there. So at 11, this train is coming in. So there are three trains at 11 parallelly. So we need to have three platforms, right? So we need to have three platform here. Now this is at 3 p.m., which is okay, like 3 p.m. is okay. And there is the intersection, but again, like we already have three platforms. So for these two, we just need two platform, right? So we already have three of them. So the minimum number of platform needed is three. So I believe it is clear with everyone what is the question basically. Let's write it down here. So let's understand with some diagrams, right? In case it is not clear. So let's clear the canvas. Okay, let's see. So one train is coming at 9. It's leaving at 9:50. One train is coming at 9:40. It's leaving at 12. One train is coming at 9:50. It's leaving at 11:20. One train is coming at 11. It's leaving at some time. Let's say, what was the time it was leaving at? So it's leaving at 11:30. 11:30. So let's draw them using lines, right? So let's say this is the entire time. This is the entire time. So at 9, train 1 comes in. So train 1 comes in and it leaves at 9:50. At 9:40, train 2 comes in platform 1, let's say. So train 2 is coming here and it will leave at 12. At 9:50, train 3 will come in and it will leave at 11:20. At 11, train 4 will come in and it will leave at 11:30, right? So 11:30, somewhere here. So if you see at this point, there are 3 trains that are there, right? Simultaneously. So basically, yes. So at this point, there are 9 to 9:10. Okay, it's fine, right? 9 to 9:10, 9 to 9:15, same thing. There is no overlap, right? So at this point, at 11, there are 3 trains at the same time. So we need 3 platforms for them, right? We need 3 platforms for them so that none of them are waiting. So this is the question. So basically the question is, how many trains can be there at max at any given point of time? How many trains can be there at max at any given point of time? To break it down further, what does this question basically tell you? The question is telling you how many trains are there such that their arrival time less than equal to the current time, less than equal to departure time. From this number of trains that are satisfying this property, that is, they are already there in that time, the count of them, you want the maximum count of them. So this is what the question tells us, right? So as Suraj said, we can just sort them with their increasing order of their arrival or departure time, and then we can check like if the next train is there is a overlap or something like that, right? We can definitely do like that. So that's one way to do. Sorting is one way to do. I'll not discuss sorting in details, right? Because I think it's I'll let you guys figure it out, right? Sorting will be very easy. I'm telling you the approach that you have to sort with respect to increasing order of their end time or start time, and then you have to develop a logic so that you can find how many trains are overlapping at any given point of time, maximum number of trains. I'll actually tell you about a much simpler method, much better method that can be used to solve many such similar problems. Basically, this is a range overlap problem. If you look into this properly, how many ranges are overlapping at any point? Maximum number of ranges that are overlapping at any point. This is the range overlap problem, right? So I'll tell you how can we do this. So the trick is basically, first of all, you take, okay, let's consider a few ranges, right? Let's not talk about time right now. You have realized, right? It is a range overlap problem. Is there any doubt with the fact that this is a range overlap problem? By range overlap problem, I mean there are multiple ranges given to you like this. This is, let's say, LR of a range. Here is another range. Let's say here is another range. Here is another range. So what is the maximum number of ranges that can intersect at any given point? So if you see this point, there are 4 ranges that are intersecting at this point, right? So this is basically the range overlap problem. So our problem is same as this range overlap problem. Does everyone agree to this? Does everyone agree to this? Let me know in the chat, yes or no. Do you agree that it is same, or do you have some doubts with this? Let me know if you have some doubts. I'll definitely try to help you there. Everyone agrees to the fact that this is a range overlap problem? Okay, Rajesh agrees with me. Others? Anyone else? Anyone has any doubt with this? Anyone has any doubt that it is not? Please, once more. Sure. So basically, what do we have? We have the trains coming in. Let's say the train is coming in at this time. Let's call this 9:10, right? Or 9. The train is leaving at 9:15. There is another train, or let's consider that part where they're coming at 9:40, right? So let's say a train is coming in at 9:40. It is leaving at 12, right? Another train is coming at 9:50. 9:50. It is leaving at, let's say, 1 p.m. or 13:00. Let's say one train comes at 11 and it's leaving at 12:30. Let's say this is a different example, right? Not the same one. So what do we want to find? At any point of time, what is the maximum number of trains that can come to the railway station together, or that can be there at the railway station together? So at 11, if we see, in fact, after 11, 11:05, 11:10, all these time intervals, we can see that at max 3 trains are coming at any point of time, right? So can we actually remodel this exact thing to a problem where we say that we are given a set of ranges, right? We are given a set of ranges. Now, in our case, the ranges will be the arrival time to departure time. So we are given a set of ranges L to R. So let's say the ranges are like this. This is the starting point, ending point. Second range can be like this. Third range can be like this. Fourth range can be something like this, right? Fifth range can be something like this. So you have a set of ranges. At any point, what is the maximum number of ranges that are passing? At any point, what is the maximum number of ranges that are passing? If you look into these points, at any point, what is the maximum number of ranges that are passing? So if you see at this point, maximum number of ranges are passing, right? 4 ranges are passing. So these two problems are the same, right? These two problems are the same. Do you agree to this, Suraj? Do you agree to this? I have just remodeled the entire thing to, instead of talking about station, arrival time, departure time, I'm just talking about ranges. That's a range L to R. I'm drawing the ranges, and at any point of time, how many ranges, like what is the for a given point, how many ranges are passing through that point? We have to find the maximum, right, for any given point. Both of these are same. So basically, this is start time to end time, arrival time to departure time, and this is time, any unit of time, right? So both of these are same, right? How will we solve it? To solve it, let's consider a set of ranges, right? 1 to 3, 2 to 4, 2 to 3, 5 to 6, 6 to 8, right? Let's consider this set of ranges. Link is in the description. Let's consider these questions, these ranges. The idea is, just see, we'll take a array of size whatever is the maximum right hand limit plus 1. So 0, 8, right? We'll take an array of size, like index will be up to 9, that is 10. 3, 4, 5, 6, 7, 8, 9, 10, right? Initially we'll set everything to 0. Initially this entire array will be only 0, right? So what is the size of the array again? Or what is the last index? Maximum on the right hand side. Whatever is the maximum value at the right hand side plus 1. That is the maximum index, right? So that is, if you see, 9 is the maximum index. I don't know why have I written 10. 10 will not be there up to 9. Okay. What we will do is just a simple thing. In this array, let's call this array P. We will do P of, whenever we see a range L to R. Whenever we see a range L to R, we will do P of L plus plus. We will do P of R plus 1 minus minus. We will do P of L plus plus. We'll do P of R plus 1 minus minus. And that will do. How? Let's see. For 1, 2, 3, we will do P of 1 plus plus. P of 1 plus plus, it will become 1. P of R plus 1. P of 3 plus 1 is 4. It is minus minus. So it will become minus 1. It will become minus 1. Again, 2 to 4. P of 2 plus plus. P of 2 plus plus. So P of 2 is plus 1. P of 4 plus 1, that is 5, is minus minus. 5 is minus minus. 2 to 3. P of 2 plus plus. So 2 will become plus plus, means it is already 1. It will become 2. P of 3 plus 1. 3 plus 1 is 4. P of 4 minus minus. So it will become minus 2. 5 to 6. P of 5 plus plus. P of 5 is minus 1 right now. Plus plus means 5 is 0. Minus 1 plus 1 is 0, right? And you don't have to have these ranges sorted. Although I have written it in a sorted way, you don't have to have these sorted, right? You can do it in any way. P of 6 plus 1 is 7. P of 7 minus 1. So it will become minus 1. P of 6 plus plus. P of 6 is 1. P of 8 plus 1, that is 9. It is minus minus. 9 is minus minus. So minus 1. And you are actually done. What you have to do after this, you just have to take a sum across. You just have to take a prefix sum. You just have to take a prefix sum. Just see what has happened. We will do the changes in the same array P itself, but I'm just writing as P dash, right? Just so that you understand better. So we'll just take a prefix sum on this array. So 0 will remain 0, 1 will become 1. This will 2 will become 2 plus 1, 3. This will become 3. Minus 2 will become 1. This will remain 1. Plus 1, it will become 2. It will become 1. It will remain 1. It will become 0. No, we don't need to sort. In this logic, we don't need to sort according to departure time, right? So if you see, at time 2 or at point 2, 3 line segments are intersecting and it is maximum. At line 3 as well. How did we get that? If you think about this carefully, we are incrementing P at L when the line segment is starting. We are also decrementing at R plus 1 when the line segment is ending, right? So if you take a sum, if you take a cumulative sum, when it reaches L, the cumulative sum becomes plus 1. When it reaches R, it becomes minus 1. So the influence of L to R, this range, it remains in the range L to R, right? It is added in the range L to R. At R plus 1, it becomes minus 1. So that is how it is working. So let's actually verify if it is true. So 1, 2, 3. 1, 2, 3. Just see the ranges. Let's try to draw here somewhere. 1, 2, 3. 2 to 4. 2 to 3. See, at point 2, there are indeed 3 line segments, right? At point 3 also, there are 3 line segments. So this is actually giving correctly. This is actually giving correctly. And you don't need it to be in a sorted fashion, right? Let's say 2, 3 comes later. You just add it later, plus 1, minus 1. Because eventually, when you are doing the cumulative sum, the actual value is, you are getting the actual value, right? At the cumulative sum. So you don't need it any sorted. You don't need in any sorted order, right? So is there any doubt with this approach? How is this working? So you just do P of L plus plus, you just do P of R minus minus. And this is a very, very useful topic. Whenever you have such operations where you have to update on ranges, this is kind of called the range update point query, right? This is called the range update point query. So basically, if you have a question as well, like where you are given two queries, where there are only updates, right? And you have to update in this range, you can just do the same thing, and then later on, like in offline way, you can actually answer what is the value at every index after those updates, right? So this is the technique, P of L plus plus, P of R minus minus. Is this clear with everyone? Similar questions, there is a lot of similar questions, right? There is a lot of similar questions. One will be like scheduling tasks, like you have to schedule tasks in some way, or let's say train station is the popular one, I would say. Then there can be a range update point query, right? So you are given a question, like let's say, let's clear the board. First let me tell me if this is clear with everyone. Is this clear with everyone? How is this working? So P of L plus plus, when you are actually taking a sum, what do you do? Sum plus equals to P of I, right? You do it like this, you are taking the running sum. So when you reach L, you do sum plus equals to 1, because P of L plus plus. So basically the range L to R, its contribution gets added to this sum. When you reach R plus 1, L to R is complete, right? So its contribution is subtracted from the sum. So that's how it is working. That's the main motive, right? P of L plus plus, the main motive is add the contribution of the line to the sum, because you are taking the sum from left to right. So L is definitely less than R, right? So when you reach L, like when you reach 1, you know, or when you reach 2, there are two lines, right? So P of L was 2, right? So you did plus 2 to your sum. Basically, there are two lines starting here. Similarly, when at 3, we see that two lines are ending. So that's why we do minus 2. That's why we do minus 2, that, hey, two lines are ending here at 4. Suraj, is it clear to you? Is it clear to you? Why are we doing plus plus minus minus? Just see from this array. At point 2, two lines are added, right? Two lines are added. At point 4, two lines are completed. This line and this line is completed. So that's why minus 2. You have to subtract two lines, right? At 6, one line is at 5, one line is added. So one line gets subtracted, one line gets added. So net is 0. Okay. Okay. Similar question will be, this one is definitely another similar question is, let's say you are given Q queries. You are given Q queries where each query is of the form LR, and you have to increment them by plus 1 or plus X anything. Plus 1, plus X anything. You have to increment the ranges. After all the queries are over, you have to tell what is the value of every index I. So you have to do here AI plus equals to X for every index in this range L to R. And finally, you have to report what is the value of every AI. So same thing. P of L plus equals to X. P of R plus 1 minus equals to. Simple. Right. So this can be a similar question. But note, you have to process in offline fashion, because you have to take the cumulative sum, then only you will get the answer. Okay, so we'll do the same thing here. Int, let's call it P. The size will be 2361, let's say. Why 2361? Because 2359 is the final value possible. 2359, right? So 2361, just to be safe. Initially everything is 0. Just full screen. So for int I equals to 0, I less than n, I plus plus, P of arrival of I plus plus, P of departure of I plus 1 minus minus. And then we'll take the sum for int I equals to 0, I less than 2361, I plus plus P of I. So let's take it from 1. P of I plus equals to P of I minus. And we have to tell the maximum value. So answer equals to 0 for int I equals to 0, I less than 2361, I plus plus, answer equals to max answer P of I, and return answer. So what is the complexity for this? It is order of n, right? You are just taking an array of size order of n again, let's say. Not order of n is actually 2361, and then it's order of n basically. It's so sorting is n log n, it is order of n here, right? So it is a better approach. So let's try to submit this. Hopefully this works. Expected. So let's submit. Any doubts with this? Any doubts with this? Meanwhile, we can go to the next question. Clear the canvas. This will take some time for so let's go to the next question. But meanwhile, let me know if you have any doubt. And if you don't have any doubt, just read on this question and then I'll read it, right? So I'll just wait for 1 minute to get any doubts if you have. And after that, I'll read this question. And till then, you can read it yourself, right? Let me know if you have any doubts. Yes, yes. It is indeed a good approach. Try using this like whenever you see a problem where there are ranges and there is overlap, like you have to find overlap between ranges, just like blindly go with this approach, right? It will work in most of the cases. Just think about it. If it is working, if it is not, then definitely don't do it. But yeah, in most of the cases, it will just work. So that's there. Okay, let's read this problem. So you are given an array of n integers, ARR, where each element represents the maximum number of steps that can be made forward from that element, right? Find the minimum number of jumps P2361. Why? That is because these are time, right? These are time intervals that are given to you. These are 0 to 23, and minutes is like 2360, right? 235859, like that, right? So 0001 0002, like that, and like this. So 2359 should be the ideally the last one, and so that's why we have taken 2361. That's why. Okay, find the minimum number of jumps to reach the end of the array. If an element is 0, you cannot move through that element. Return -1 if you cannot reach the end of the array, right? So what it tells you, that you are given an array where each element represents how many steps you can jump forward. So let's say you are given an array element is 2. That means you can jump forward by maximum 2 places. You can either go by 1 place or you can go by 2 places. If an array element is 3, you can jump forward by 3 places at max. You can go to by 1 place, by 2 place, or by 3 place, right? So you can go to any number of places. So you have to tell what is the minimum number of jumps needed to reach the end, right? So for example, 11 here, 11 elements are there. So first you start up at the first element. Here you have only one option, that is one step. So you go to this. Now you have three choices. You can either come here, take one step, or you can take 2 steps and come here, or you can take 3 steps and come to 9. So let's say you take 3 steps and come to 9. In the next move, you can reach the end directly because there are less than 9 elements, right? So you can just take 1, 2, 3, 4, 5, 6. You can just take 6 steps and move to the end. So in just 3 steps, you can reach the end of the array, right? So you have to tell what is the minimum number of steps needed to reach to the end of the array, right? So similarly here, first you have one step at you can take only one step. So you can just go to 4. From 4 you can go to 3, 2, 6, 7. So you will just take one step and go to 7 directly. That is the end of the array. So just 2 steps. In this question we find maximum of a of I. No, maximum of a of I won't work, right? Like, just say you had a different array here, right? Or you didn't have like 4 here or something, right? Maximum won't work. Like, definitely it won't work. Like, there might be better solutions than maximum. I can give you an example if you like want, but yeah. Or how would actually maximum work? You have to. No, no, that won't work. That won't work. So you are given the array and it tells how many steps you can move forward. So you have to tell what is the minimum number of steps, right? So you have to tell the minimum number of steps. Okay, let's understand this. So let's say you have something like, I'll come to your maximum actually. Let's take an example around the maximum, right? Backtracking. Uh, backtracking. If we see the constraint, it's order of n and order of 1. Although don't worry about the constraint yet, because I'll tell you worst case, not exactly optimal solutions, and then we'll go into the optimal one. But first let's understand this, right? So let's say you can take 2 steps, right? After that you can take from here 4 steps, or you can take from here 3 steps, right? So something like this, right? So here you can go to this and directly go 4 steps forward, or you can go to this and go 3 steps forward, right? Any of these work, so both will land at the same place. So one solution that should come to your mind, just seeing that you are given minimum number of steps, right? And you see that there is a clear transition that is given to you. So you are at ith index, you can go to I plus 1, I plus 2, up to I plus a of I, right? This is the clear transition that is given to you. You can already see that. From ith step, you can either go to I plus 1, I plus 2, or like that up to I plus a of I, right? Any point. So that means if you want to find the minimum number of steps, right? Let's call f. F of I will be the minimum number of steps to reach to the end from I. So what is f of I plus 1? Minimum number of steps from I plus 1 to the end. F of I plus 2, minimum number of steps from I plus 2 to the end. F of I plus a of I, minimum number of steps from I plus a of I to the end. So f of I, this directly comes to us, right? F of I equals to the minimum of f of I plus j plus 1, where j is equals to 1 to a of I. This recursion directly comes to us, right? F of I is the minimum number of steps needed to move forward, right? F of I is the minimum number of steps needed to move from I to the end. So you can go from I to I plus 1, I plus 2, up to I plus a of I. So f of I will be the minimum of whatever number of steps. Like basically from I, you go to I plus 1, and from there you go to the end. Or from I, you go to I plus 2, and from there you go to the end. Or from I, you go to I plus a of I, and from there you go to the end, right? So whichever is the minimum path, that one you will take and add plus 1 to it, because you are making one more step here. Does this make sense? Is this recursion making sense? How do we get this? Is this recursion making sense? So to clearly write it down, f of I equals to what? It is the minimum number of steps needed to reach the end from I. So what is f of I? F of I equals to minimum of f of I plus 1 You either go by one step, f of I plus 2, you go by two step, like that up to f of I plus a of I plus 1, right? So this recursion, I believe, is making sense to everyone. From I you go to I plus 1, from there you take the minimum path, or you go to I plus 2, from there you take the minimum path, or you go to I plus a of I and from there you take the minimum path, right? Whatever is the minimum, you take that. Okay. So what is the complexity? If we do a dynamic programming here, dp of I is equals to dp of I plus 1 plus dp of I plus 2, sorry, not plus, minimum of dp of I plus 2, I plus 3, I plus a of I plus 1. So the time complexity here will be n squared, order of n squared, because for state you have dp of I, which will take one loop. The transition itself is order of n, so it will take the second loop. So it's n squared, order of n squared, the total complexity for a dynamic programming solution. Is that correct? I hope you know about this, right? What is the complexity of a dynamic programming solution? You have some states, you have some transition. So let's call it f of s state 1, f of state 2, like that. So it will be total state complexity into total transition complexity. That is for one transition, what is the complexity we need? So we see that for one transition, we had to calculate f of I equals to what? F of I plus j. For j equals to 1 to a of I. So it's almost order of n, right? Transition complexity. And state complexity is order of n. One state is there, so n squared overall. So it is a order of n square solution. This will not work, right? Order of n is required. I will tell you about the optimization here, but that is not the final solution. I'll discuss the final solution, but this optimization is also only if you are understanding, then only go ahead with this. If you are not understanding, it is completely fine. You have to just strengthen on your or work on your DP skills, right? This is how you can optimize dynamic programming. Again, the solution is not dynamic programming. The final solution is not dynamic programming. It's completely different. But you can optimize this using optimize dynamic programming as well. How? We see that dp of I, again, only if you're understanding, then only try to understand, right, is minimum of dp of I plus j, where j is from 1 to a of I. So definitely before we compute dp of I plus j has to be computed. They are already computed. Doesn't this problem, now you already have computed the values, right? You have already computed the value of dp of I plus 1, dp of I plus 2, dp of I plus 3, dp of I plus a of I. You have already computed these values. Just forget about the dp word, right? They are simple array. This is a simply array, right? This is a simple array. So you already know these values. Let's call it a simple array. A of I plus 1, right? It is a simple array. You have to find what? You have to find the minimum among them. You have to find the minimum in this range of the array. So you have to find the minimum in the range I to I plus a of I. Sorry, I plus 1 to. Can anyone tell how do we find the minimum of a range in an array? I plus 1 to I plus a of I. We have to find the minimum in this range of the array. Can anyone tell how can we find efficiently the minimum of a range in an array? For multiple ranges, you are given multiple ranges, you have to find the minimum. How can we do that? Anyone tell? Can anyone tell? How can we efficiently find the minimum of the range of this array? Can anyone tell how can we find this? Can anyone think of a way? You are given an array. You are given an array. You have to find minimum of a range. How would you find this efficiently? You are given multiple ranges. Let's say you are given multiple ranges. You are given an array. How do you compute quickly the minimum of a range of the array? How do you compute quickly? So this is same, right? This is same as you are given Q queries. In each query you are given L to R. You have to tell what is the minimum in the range L to R. You just have to tell this minimum in the range L to R. How do we do these problems? We use something called a segment tree. So here also we can use the segment tree because it's minimum of a range, and that will reduce the complexity to n log of n. But with 10 to the power 7, n was 10 to the power 7, n log of n won't work as well. So now we'll come to the actual solution about how to solve it in order of n time. So there is the order of n solution as well. But this is the idea. This is the overall idea. Like you might actually use this segment tree approach as well in your interviews, definitely. So you can use a segment tree to optimize it to order of n log n. Again, this is not necessary. Our solution will be much simpler, right? So what we will do is we will do a greedy like solution. How do we do this? Not exactly a greedy. We'll do a, it's not a DP as well. We'll just do a iterative ad hoc type solution. So we'll maintain a few variables. Let's take an array and understand, right? Let's take an example. 1 3 5 8 9. Let's take the second. Let's take this. 1 3 5 8 9 2 6 7 6 8 9. 1 3 5 8 9 2 6 7 6 8 9. Okay. We'll maintain a few variables. The first variable that we maintain is what is the maximum position that we can reach. So let's call it maximum reachable position. Maximum reachable position. What is the maximum position that we can reach, right? The second will be what is the number of steps that we can take, steps left, number of steps left or number of jumps left. That is, we don't increment the jump immediately. When we make a jump, we do not increment the jump. Will not increment the jump. The third variable will be jump. How many jumps we have made till now? Jumps we have made till now. But we do not increment the jump when we are making a jump, right? We will increment the jump only when we are getting over the steps from the previous jump. Only then we will make a jump, right? Not exactly we will make a jump before that only, but the jump variable will be increased then. So we'll initialize this to ARR 0. Maximum reachable position will be initially ARR 0, whatever it is content. So it is 1. Steps left will be ARR 0 again, whatever it is there, 1. Jump will be initially 0. Initially jump will be 1 as well because we have made one jump. We are here, right? We are here. At 3, I think jumps can. We'll see. Right? Now we'll start off at index 1. We'll start off at index 1. We will first compare. We'll update the maximum reachable position. The current reachable position is 1. What is the reachable position if we come when we come to 3? It's 3 plus index 1, that is 4. We can go up to index 4. So let's mark the indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from here we can go up to index 4, 3 steps, 1 2 3. So maximum reachable position is updated to 4. Then we do steps left minus minus. Steps left minus minus. So that is steps left becomes 0. Whenever steps left is becoming 0, whenever step left is becoming 0, that means we are over with the previous step. The previous jump that we have made, we are over with that. So it's time for us to update our jump. That is, we have to consider our new jump. So that time we'll increment our jump counter. So jump counter is increased to 2 now. Okay. Now we will go to I plus plus. We'll go to 5. What is the maximum reachable position from here? It is 5 plus 2, that is 7. Is 4 bigger or 7? 7 is bigger. So we can reach maximum 7. But here we are not making a jump. We are just marking that, hey, if needed, we can make a jump to 7. Whenever we need, we can make a jump to 7. Right? Steps left. Also, we have to update the steps left. Step left will be updated to 1 minus 4, that is 3. So now we have to do steps left minus minus. So it will become 2. It will become 2. Jump, we will not do anything because it is 2. Again, we are not over with the current steps from the second jump, right? Second jump we have done from 3. We can go up to this 4. So we are not over with the current steps. Now we come to 8. From here, we see we can go up to 8 plus 3, that is 11. We can go up to index 11. Maximum reachable point is 11. And we'll do steps left minus minus, that is, it will become 1. After that, we will move forward. We'll come to 4. Now here, maximum reachable point will be 9 plus 4. If we come here, we can directly jump from 9 steps forward. That is 9 plus 4, that is 13. 13 is the maximum reachable point. Steps left minus minus, so it becomes 0. Now when it becomes 0, we know that a step is over. The previous step that we have taken from 3, it is coming to an end here. So see, we have already recorded what is the maximum jump that we can make in between. We have already recorded that in the max reachable position, and we'll make that jump right now. So now steps left becomes 0, so we'll increment our jump. So jump, we made another jump, and the steps left will be updated, right? We have made a jump already, so we are at 4 and we can go up to 13. So how many steps have we already taken? 13 minus 4, 9. So 13 will be here. 9 steps are remaining. You can take more 9 steps. That is, you have to end at 13. Right? You have to end at 13 because you are taking that move. The move that we have taken is 9 to 13, that jump. So we are left with 9 steps, which is true, right? We have taken this one. Next, we go here. See, in the remaining part, only our max reachable position and steps left will get minus till we reach the end, right? So our jumps will be returned to be 3, which is actually true. Jumps will be returned to be 3, which is actually true. So that is basically how it is working. To tell you about the logic overall, how is it working? We are basically making jump whenever we are. So we are, let's say we have made a jump from I, we can make a jump up to J. That is I plus 1, I plus 2, all these are valid jumps. So in these parts, we find what is the maximum that we can reach from these points. Once we are over with the jumps, now whatever maximum, let's say from here we could have made the maximum jump. So we make that jump and we increment our jump counter, and the steps left will be whatever is the maximum index minus how many index we have come, right? So that will be the steps left. So like this we are proceeding. So to write the code for this, let me know if the logic is clear with everyone. How is this working? Is the logic clear with everyone? Is the logic clear? Is the logic clear? Okay, repeat. I'll repeat again. Let's take a different example. 2, 2, 4, 6, 3, 1. Let's say like this. We have added like this. Let's understand. So how many steps are needed? 2, we can go to 2, 4. From 4, we can go to the end. So 2 steps are needed, right? What we'll do, we'll start from, we'll make the first move. The first move has to be made. So we'll start from index 1. So what are the variables? Max reachable. Max reachable will be what? Index 2. Because we can take 2 steps. 0, 1, 2, 3, 4, 5. We can take 2 steps. Steps left. We have 2 steps left still to make. And jumps is 1. We have made 1 jump already. The first jump has been made. Now we are at 2. So we will update our answer. Max reachable is what? Basically, if we come to 2 and make a jump, what is the point we can reach? So 2 plus 1, 3. So max reachable will be updated to 3. And steps left minus minus. So steps left will become 1. So steps left means one step you can still make from the previous jump. You can still make 1 step from the previous jump, right? So you will not update the jump yet. We have not made the jump yet. We'll make a decision once we are done with the previous step completely. We'll come to 4. We'll come to 4. Right. We will come to 4. At 4, actually what we are doing is we are just grouping over all the values and we are finding what is the maximum reachable we can go to. Right. If you look into this, that's what exactly what we are doing. We are going like we are here, we'll directly go to all the next possible moves and there we'll figure out what is the maximum we can reach, right? And then we can increment the jump accordingly. So when we are coming to 4, actually we can do it in a much simpler way. Like just from 2 we can explore. From 2 we can go to 2 places more, or from this 2 we can go to these 2 places. So we'll just come to these 2 places and figure out what is the maximum jump we can make, and then take whatever is the maximum value once we reach this to this end, right? We'll take that jump and we'll update our yeah, we'll then continue our quest. Okay, so yes, and again we'll continue in between after that. That's kind of the logic, right? So anyways, we are basically incrementing whenever needed. So now we have come to 4. We'll do what? Max reachable is 4. Now from 4, if we come to this 2, we can go 4 steps. That is max. 4 plus 2 is 6. We can directly go to index 6. So that's the max reachable. Steps left will mark it 0. Now as the steps left is 0, we know that we have to make a jump now. So the second jump we will make, and what is the second jump that we have made? It is actually this one, the maximum reachable, that like from 4 we have made that jump. So 4, how many steps have we already taken? We have already taken 4, that is 6 minus 2, that is 4 steps we can take more. 4 steps we can take more, right? So after that we'll go to the next page. See now, just the steps left will be like this is updated to 6, 7, 8, 9. This will be updated to 9. This will become 3. Then we'll go to the next place. 4 plus 3, 7. This will not get updated. It will get updated to 2. This will get 5 plus 1, 6. It will get updated to 1. And finally, once we reach, it gets updated to 0. And we have 2 jumps we have done. Right? We have done 2 jumps. So kind of, you can also think of it like this, that hey, from here we are making these set of we can make these set of jumps. You find whatever is the maximum and you will try to go there and take the jump then, right? So that's kind of like you always try to take the maximum jump out of them. So basically it's a greedy like solution where you just try to take the maximum jump possible at every point and try to reach to the end, right? So anyone has any doubt with this? So you are trying to always take the whatever is the maximum position that you can go up to. Not only that, you are also yeah, right. You're always taking the maximum jump and then you're exploding in between, like if you have to take a middle jump or something, right? So basically the idea being that what you are doing is just to like make things a bit simpler. Let's take this example. So what you are doing at every point, you are just trying to make the best possible jump, right? So from here you know that whether you can make one step, so you can go to 3, from 3 you can make a jump 5, 8, 9. So you always try to make the best possible jump, but when you make the best possible jump, you directly don't go to that jump point, right? You are making the jump at 9, but from 9 where do you go? You can go up to 9 places, but you figure out in between as well what is the best possible intermediate jump that I can make, right? What is the best possible intermediate jump that I can make? Because you can make any jump less than 9. So kind of like a greedy approach that we are doing, and that will work because why? You are considering the intermediate. It's not like you are taking 9 steps at a time, or you are just going to by 3 steps at a time, right? You're not going that, you are going through the intermediate steps as well, that hey, these are the jumps that these are the points that I can reach. So we can take jumps here as well. We can break our, like we can take, instead of taking a jump 9 steps, we can take a 2-step jump as well, or 3-step jump as well. We are going through all the intermediate parts as well. So that's why this is working. Just like let me write the code. I think that will make it much simpler. So int, first is int, what is the maximum reachable point that we can go up to? Maximum reachable position point, let's call it. Initially it will be ARR 0, whatever is the value of ARR 0. Steps left, what is the number of steps that we have left? That is basically what will be steps left. It is also initially ARR 0. You can take those many steps. Number of jumps that we have made, so jumps will be equals to 0 initially, 1 equal. Now a few cases, if n is less than equal to 1, that is only one element is there, so in that case return 0. Else if ARR of 0 equals to 0, that is you cannot go anywhere, so return -1. A problem link is in the description. Now we will start off at I equals to 1. We'll start off at I equals to 1 because we have already made the first jump. So while I less than n, right? While I less than n. So if we have reached the end, I equals to n minus 1. If we have reached the end, so we'll just return the number of jumps that we have taken till now. Jumps, right? Otherwise, what we'll do, we'll update our max reachable position. So max reachable point equals to, we can make a jump here as well. So max of, we can come here and then make a jump. Max of whatever is the max reachable point, max of max reachable point, and I plus ARR of I plus ARR of I. Max of max reachable point or I plus ARR of I. We make a jump, we can make a jump here, right? We are taking a step, so now steps left will be minus. So steps left is how many steps are left from the previous jump that we have made. How many steps are left from the previous jump that we have made? So initially it is ARR of 0. So let's say ARR of 0 is 2. So for step 1, it will become 1. So there is one step left that you can take still, right? So we will only make a jump to be valid only when we are actually sure that we have to make that jump, right? So when are we sure that we have to make a jump? When our steps left is 0. When our steps left is equals to 0, we are sure that we have to make a jump here, right? So we'll do jumps plus plus. But here we'll make a conditional check as well, that hey, if the max reachable point is equals to I, that means there is a value 0 somewhere. Max reachable point is I, that means we cannot make a move. I plus ARR of I, ARR of I is 0, so we cannot make a move beyond I, right? So that means it is, we will return -1 because we cannot make a move beyond I. Because see, max reachable point is updated to I plus ARR of I, right? Now if ARR of I is 0, then I plus ARR of I will be I, and we are telling that even previously also the max reachable point is not more than I. So that means we cannot move beyond I. We cannot move beyond I. So we'll return -1. And what will be the steps left? Steps left will be equals to whatever is the max reachable point, we can make steps up to that point, and whatever step we are at right now, we are at I, we can make step move up to max reachable point, we can go up to max reachable point. So these many steps are left. So fine, and finally it doesn't matter, we can return 0, -1, anything. The code will never come to this portion. The code will never come to this portion. And also we have to do I++, definitely. I++. So is the logic clear? Like what we are doing? See, initially we are making the first jump. ARR 0 is the max reachable point. Steps left is ARR 0. We can take those many steps, and jumps is 1. Now we start off at 1, index 1. If we see that we have reached the end of the array, then we'll return the number of jumps that we have made. Otherwise, we will not make a jump unless we have to make a jump. That is, if we have steps left. Steps left means how many steps we can go further forward from the previous jump that we have made. From the previous jump that we have made, how many steps we can go further. So steps left minus minus. If steps left is 0, that means we cannot go forward anymore. In that case, we have to make a jump plus plus. And what is the jump that we'll make? We'll always make the best possible jump, max reachable point, because making a lesser jump doesn't make any sense. Because from the max reachable point as well, we can go, it is not that we have to reach to that point only, we can reach anywhere up to that point. So we'll always make that jump, we'll always make a jump from that basic point, because we have more places we can cover, right? Now we have a condition that, hey, if max reachable point right now is equals to I, that means we cannot go beyond I, so we'll return -1. Otherwise, what is the number of steps left? We are reaching max reachable point, we can go up to that. We are standing at I, how many steps we can take more? Max reachable point minus I, and we'll do I++. So that's basically the code. So let's run this. Is this clear with everyone? How is this working? So it's always better to make a good move, right? It's always better for us to make a move. If you can take, if you are like, if you can, let's say you are told that, hey, you can take 10 chocolates, any number up to 10 chocolates, or you can take any number up to 5 chocolates. You can take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which one is better? It's always better to take 10 chocolates, right? You can take any number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whichever suits you, right? So that's why it is always better to take the maximum, like whatever is the best move that you can do. Because you get more choice. You get more choice in between. Is it clear? Is it clear with everyone? Let me know if you have any doubts with this. Okay, Sai. Rajesh, is it clear with you? Okay, it's clear. Good. So yes, so that's it. Let me know if anyone has any doubts. We'll wait for 1-2 minutes more, and then we can end. So if you have any doubts, let me know. I'm not giving any homework for today, but from the next class, just like so that you can get started. And today's problems are also pretty good, so you should go and like recapitulate on them. Uh, yeah. Let me know if you have any doubts. From next class, I'll be giving a lot of problems, right, for homework. So I don't know if you know the schedule already, but the schedule will be Monday, Wednesday, and Friday. Every day we'll do it around 7:30 p.m. If I am not available, like today I was not available at 7:30, so I did it earlier. So you'll get to know the time beforehand. Monday, Wednesday, sub days Monday, Wednesday, Friday. So next Wednesday, 7:30. The classes will be from 7:30 to 8:30. In case I have some problem, I might prepone it. So you will get to know like just on Wednesday morning or around around post 4 p.m. Just check once if when the class is scheduled for. Okay. Cool. If you don't have any other doubts, let's end the stream here then. Thank you guys for joining, and I'll see you on Wednesday.